How's it going, guys? Welcome back. My name's Nick. This is my friend Matt Trevina from MT Performance Engines, and in this video we'll be building my new 7AGE engine. So I'm here today with Matt at MT Performance Engines. He's putting my engine together for me today. And so tell us a little bit about yourself, mate, and MT Performance Engines.
How you going, guys? I've been in the industry a long time. I specialise in Toyota 4AGEs. It's what I have myself. I also do SR20 Nissans, RBs, 2Js, just the standard import sort of stuff. Today we're building Nick's 7A FE bottom end with a 4AG 16 valve top end. Thing's been ported, oversized valves, bigger camshafts, solid conversion in the shimless region. And yeah, we're going through the whole process from start to finish with girdle adaptation, forge rod and piston combination. And yeah, we'll just, this is what we do.
So I thought I'd give you guys a quick rundown of the setup of my engine. I'm running a baffled and gated sump. I'm also running a crank girdle. We've super finished the crank and the oil pump gears. We're running King rod bearings and ACL main bearings. We couldn't source ACL rod bearings for a 7A FE engine, so that's why we're running the King rod bearings. We're running spool rods, CP pistons, TRD head gasket, ARP fasteners throughout, Supertech valves. We're running 1mm oversize on the intake and 2mm oversize on the exhaust. We're running Supertech valve springs, which have 60 pounds of seated pressure, titanium retainers, Kelford 193 HVA cams, which have a 290 degree intake cam and a 282 degree exhaust cam. The intake is running 10.3 millimeters of lift and the exhaust is at 10.1 millimeters. We're running a solid shim conversion, Expert 525cc injectors, a fully ported head, blacktop throttle bodies, also running a drive-by-wire system, Toyota 4-2-1 headers. We will be running E85, but I do have a flex fuel sensor just in case the E85 isn't available. I'm running genuine Toyota gaskets throughout. All the seals are also genuine Toyota except for the valve stem seals, which are Supertech. Matt decided to run Supertech valve stem seals due to their resistance to E85 fuels. My oil pump and water pump are also genuine Toyota parts. So we had to send this engine back to the machine shop for a couple of alterations, one of which was the crank girdle pulling the main bearings out of spec. Matt did a ton of measurements on the engine before he actually assembled it, and one of the problems was the girdle was fine when you torqued it down on the main bearing caps, but as soon as you torqued down the sump bolts, it would pull the bearings, the main bearings, out of spec. So that's one of the benefits of going to a really experienced engine builder, because I think that's something I never would have picked up myself. The other alteration that we had to make was that we wanted to have a 0 deck height, and standard 7AFE blocks actually run a 0.6 deck height, so we just had to correct that and we were good to go. So what you're seeing Matt doing there was he was just checking for thrust. He didn't quite have 3 thou that he was looking for, so he loosened the main bearing caps, gave the crank a tap with a hammer, and it brought it back into his 3 thou spec. So now I'm just going to be quiet for a little bit and let you enjoy some raw footage of Matt assembling my motor. You never locked it? Do you ever Loctite those bolts?
I do, so what you got to do...
Do they sit up against the block though, these ones?
Yeah, they do.
They're not going to back out anyway.
If they back out, the plate will flex and the liquid will come out the side because they're under extreme pressure. But I'll show you what you do. There's a trick to these because you have to tighten them down. Test the pump spins. Then you one at a time back out, Loctite back in.
Okay.
So I have to now make sure my pump spins.
Yeah.
So she does. She's fucking tight because this stuff is very tacky. It's a very tacky stuff.
Yep.
So that's good. She still spins. So now I'm going to get my trusty red.
It may not spin if you just haven't got it quite lined up when you put it together.
Yeah, if you put one bolt in the hole first, and then you decided to Loctite that in, just line everything else up by eye, and then you put the next one in. Although they're tapered heads and they align the pump housing,
it may pinch it.
Yeah, if it moves off just to the side, just a touch, it will lock the pump up.
I never would have thought. I would have just whacked it together.
Yeah. Like I say, it's it takes a long time to sort of get an understanding of how everything works. See that?
I think that was just thunder.
Was it?
What do you think it was?
I don't know.
T-Rex.
We used to be able to hear the Holsworthy Army Barracks firing off military mortar rounds and stuff.
Yeah, dead set.
Yeah, from here.
Oh, dead set.
Yeah, we used to. I haven't heard it since I was a kid.
Is that what it sounds like?
Yeah, like banging, booming. I can't imagine what the people at Holsworthy used to think of it. Alright, so one of the problems I see with some people when they put circle lips in the piston is in a high revving engine application, when you go over 6,000 RPM, you're doing 100 times a second, this piston will be going up and down. At 9,000 it's 150. So consider the fact that you've got a circle lip that's insidewards and it's actually flexible. So what will happen is the piston clip can actually squeeze and jump out of the hole if inserted this way. I see this a lot with engines that I pull apart where unexperienced engine builders do this. So the best way to put it in is vertical like this. Can't actually jump out. I guess you sort of learn these things as you sort of go through. It's a little trick I learned off one of the boys years ago to put a ring on. Bit of magic, eh?
What'd you do exactly? You put in like that?
Yeah.
Alright.
Over the top. Done. Ring gaps, opposites. The little part numbers here always face the top. They are directional. This is a scraper more than
ring. Yeah.
So that's ready.
Did you use anything other than Hylamar on the remain? You just use the gasket, Hylamar, and that's it?
Oh, the metal gasket, yeah, plus Hylamar, and then I use a engine oil inside the actual seal.
The seal, yeah.
Yeah, because if you do it dry, they will tear, they will overheat, and they get hot and they lose their memory.
Yeah.
So I will put oil in there. Some people use Vaseline, OEM use Vaseline. If you buy like a brand new Nissan oil pump for an SR20 or something, there's Vaseline in there. But I will use engine oil. I don't use assembly oil, because we have used assembly oil in the past and it fucking leaks.
Yeah, that's it.
Yep, it always leaks. Some, like this assembly lube I'd probably use, but I just don't. I just use engine oil. So you can probably see that I've stacked a couple of washers here to hold the center main in whilst I do my rods.
Okay.
Because with the girdle on, I can't actually get the stretch gauge in there.
Right, yeah.
So I know, because we've already tested the crankshaft, remember, with the mains?
Yeah.
So now we know that crankshaft turns fine.
Yeah.
So we're going to go ahead and take that back off. Just hold in the center cap. These other caps are going to be held in by the pressure sidewards on them.
Yeah.
So they'll just hold there whilst I do this. I did select the center main obviously because that's where we're thrusting from, and I've already set the thrust.
You've set it, yeah. So you just never took it out. So, really cool.
So that's settled.
Yeah.
So now it's just now we're focusing completely on rods and pistons and the oil pump locking up.
Yeah.
The oil pump obviously. I mean, I don't expect it to lock up. But you do these tests anyway.
Just to be sure.
Because if for whatever reason it's locked up, we know we've got a problem.
Yeah. When you pulled the girdle off, there's no risk of it moving then, once you've pulled the girdle?
No.
It's going to stay still.
These caps, I can't actually pull them out. I actually physically have to pull these out because they are actually pinned in here and here. They're interference fit.
Yep.
When you push the cap down, it actually spreads the block slightly.
Okay.
So these have no fear of falling out, and the thrust, I will double check the thrust at the end. Once it's all checked, I will double check that thrust and the cycle of the engine. Once you've done enough engines, you sort of know how hard an engine should turn with one rod in it, 2, 3, 4, and then you know by the time you hit six cylinders, the ring tension is so hard that the engine is actually hard to cycle.
Yep.
once it's tensioned, you'll feel for thrust, but these are pinned, so they're actually doweled. So the caps are doweled to the thing. So now what I'll do is that the dowels have been pulled closed. That rod's now complete as an item. What I'll do is I'll pull these out, measure these one at a time, put them back in.
Right, is that to do your stretch, you mean?
Just do my stretch.
Yes, okay.
So now what we're trying to do is measure the rod. This has been tensioned at 55 foot-pounds. Okay, so it's exactly 2 inch, 1/8 thou and a half. So we write that out like this. 2.0085. That's our size, inches. Alright, so during the assembly process we found that the manufacturer supplied tension settings on the bolts for these forged rods happened to be a little bit incorrect and outside of the tolerance. We tensioned the rods to the manufactured recommended setting, which was 55 foot-pounds, 3/8 ARP bolt. Then we measured the inside using an inside micrometer, referenced to an outside micrometer. And for any engine builders or machinists, they understand how these tools work. We measured the inside vertical hole of our rod and came up with a size of 2 inches, 1/8 thou and a half. Now, the factory tolerances have to be 2 inch and 1/8 thou and 2 inch and 7/1000 of an inch. So we were 1/2 thou outside of our range. Now, after cross-referencing to our rod bolt stretch gauge, I have in my head the figure of a 5.5 thou stretch on the rod bolt. When we stretched the bolts on this rod down to 5.5 thou of rod bolt stretch using the gauge, it came into our size of exactly 2 inch and 1/8 thou. So the tension wrench, not saying it was lying, but it definitely wasn't the most accurate means of tensioning a bolt down.
Yeah, when I first started looking into building 480s and stuff, I always thought that magic number in horsepower is 200 horsepower, you know, or 150 kilowatt, you know.
Everyone wants that figure, and it's not an easy figure.
Magic figure.
It's not, mate. How many people have you seen do it?
Yeah.
You know, like, it's a hard number to get. I can't remember where Adam Hocker's was. 150 kilowatt. Is that 200? That's
200 horsepower. Yeah.
Yeah, he was about 150 kilowatt, I think. Aspirate. I've done that motor for him a long time ago, and he was a 310 296 Tome Pro Cam, oversized valves, blacktop throttles. You know.
You say 1.6?
1.6, yeah. He had to rev the clapper out of it. He was revving it to 9250. 9250. That was the first big foray that I'd sort of attempted, and the results were good. Lasted a long time. That was a street car, daily driven. It was fine. That's probably the amount it's going to take. 5.5. So they're claiming that 55 pounds was enough. 77 foot-pounds is where it ended up.
77. Oh, so did you actually measure it when you tensioned it?
Yeah, I'm changing the tension to suit the stretch.
Yeah.
To see where the bolts are actually taking it.
I just thought the last one you did was by hand.
No, I moved it up just a touch.
Yeah.
0. Let's see if this one gets some wingo. Five and a half. Yep. Cool.
Well, that'll be it for this video, guys. I hope you enjoyed it. Be sure to like, comment and subscribe, and hit that notification bell if you want to see the rest of this engine build. Thanks, guys.